A little bit different than the last one because it has a leading coefficient other than 1, this 3 here. Although it's going to start the same way as the others. It will be a little bit different after that. First, group the first two terms together. Leave a space, and then put 27 off to the side with the space equals 0, just like we did before. But this 3, we don't like it being there, so we are going to undistribute that 3 to the outside. So we're going to divide that out, and so now we just have a good old x squared. 24 divided by 3 is 8x. There's still a space here. There's still 27. It didn't get divided by 3 and equal to 0. We kind of actually ignore that 27 almost until the very end. Now, what we are going to do is we are going to take this 8, not the 24 at the beginning, and we're going to go off to the side and take half of 8 and then square it to find that perfect number that will make a perfect square when we factor. So 4 squared is 16. It is 16 that we want to add into the equation, but here's the problem. This is not a 16. It lives inside these parentheses with a 3 on the outside. It turns out that you need to treat it like a 48. 3 times 16 is 48. So we are going to subtract a 48, not a 16. Now once you've done all of this, divided out the 3, remember to take 8, not the original 24, take half of it and square it. And remember that this is not a 16, it's actually a 48. Now all your work is done. We just take this 3, factor the polynomial into 2x plus 4, since 4 times 4 is 16 and 4 plus 4 is 8. 27 and negative 48 is negative 21. Is that true? Yes. Equals 0. So we're done. We just completed the square even though the leading coefficient wasn't 1, but we're not done yet because they want us to solve it. And when they say solve, that means find the zeros, find the roots, find the x-intercepts. It's the same thing you've been doing for the other two examples, and we'll do for the next one. We are going to un-PEMDAS this by dismantling it step by step. 3 times x plus 4 squared is now equal to 21. When I divide by 3 on both sides, now x plus 4 squared is equal to 7. I can tell that I'm going to get answers that are not whole numbers or might be needed to be written in radical form. I'm going to square root both sides, and when I put in a square root, I know that means that I'm going to get 2 answers. Here's what they will look like. X plus 4 is equal to, now this I feel is the best way to go about doing this problem, the positive and negative version of 7. So when I subtract 4 on both sides, the way I'm going to write my 2 answers is negative 4 plus and minus the square root of 7. That, I think, is the simplest way to present the 2 roots. You can actually calculate them. You can take negative 4 and add it to the square root of 7, or take negative 4 and subtract it with the square root of 7 and get decimals. But I actually think leaving it like this is much nicer, and you don't have to pull out a calculator.